Today we are going to study projectile motion. So projectile motion is a two-dimensional motion, and two-dimensional motion is that type of motion in which an object moves in such a way that we need two coordinates to express their motion, and during the course of motion two of its coordinates change, that is both x coordinate change and y coordinate change. And projectile motion is that type of motion in which when a body is thrown with some initial velocity is allowed to move under the influence of gravity. So if you are throwing a stone, a body with some initial velocity u, which can be resolved into two components, u cos theta, that is the horizontal component, and u sin theta, that is the vertical component, it will follow this very path and will reach B. The motion executed by the body in this case is known as projectile motion, and the body which is showing this motion is known as projectile. The path shown by the body is known as trajectory. The maximum height attained by the body is from this point to this point, and the maximum horizontal distance that is traversed by the body during the course of motion is known as projectile motion. The time taken by the body to reach from point A to B is known as time of flight. Now there are three expressions that we are supposed to derive in this case, that is the time of flight, maximum height, and the horizontal range. Now consider projectile thrown with velocity u making an angle theta with the horizontal as shown in the figure. Let the angle be that the velocity of the projectile makes with the x-axis be theta. So it can be resolved to two components, ux and uy. Ux will be u cos theta y, because cos theta is equal to ux by u, ux is equal to u cos theta, and sin theta is equal to uy by u, uy is equal to u sin theta. Now as you know that this very component will be equal to this very component because they are opposite sides of a parallelogram, so that will be u sin theta. Now when we have to discuss we have to find the expression of time of flight, we will find the time of rise. That's the time taken by the body to reach from point A to point P. The time taken by the body to reach from point A to P is known as time of rise, and that's called time of fall. That's the time taken by the body to come from point P to point B. So how can we derive it? Consider vertical motion of the projectile from A to P using first kinematic equation motion. When we are considering the vertical component of the motion or vertical motion, we will only discuss the vertical components, not the horizontal component. So we will say V is equal to U plus AT from the first kinematic equation of motion, but instead of V we will write here Vy, instead of U we will write Uy, and instead of A we will write Ay. So we have got Vy is equal to Uy plus Ay to t. Now what is the Vy? Vy is the final velocity at point P, vertical component velocity at point P, and vertical component velocity at point A. Now you know that when a body is moving in this direction, the vertical component is diminishing and it's becoming 0 at point P. That's why it's not further going upwards. It's stopping and going downwards. So vertical component at point P is 0. So we will substitute Vy as 0, and Uy is u sin theta as we have seen at the very outset, and Ay is equal to minus g. Why it's minus g? Because when the velocity of a body is decreasing, we take it as negative minus g into t. So we can say that 0 is equal to u sin theta minus gt, gt is equal to u sin theta. It implies t is equal to u sin theta by g. This is the expression for time of rise. But since I told you that time of flight is equal to twice the time of rise, so the expression for time of flight will be 2u sin theta by g. So this was the expression of time of flight. In the next video we are going to discuss the expressions for maximum height.